In this video, I'm going to show you how you can store encrypted data inside of a PNG. So, like an image file. You know what this PNG says? You're awesome. But she does too. Okay. Hi. This is Sammy, by the way. So remember to subscribe for more videos like this in the future. She really wanted to get back to her bone. Firstly, we're going to need to go ahead and install Pillow. Pillow is a pip package that allows you to interface and change stuff for images. So if you want to follow along, go ahead and install Pillow. We're also going to be using a Jupyter notebook because we're going to be creating some really big arrays for a lot of RGB values. So if you don't know how to use Jupyter notebooks, pretty simple, but you can check out this video right up here and yeah, you'll be good to go. But that being said, you don't really need to use one. If you do want to follow along, you can just have this in a file and it'll still work fine. All right, so our first thing we've got here is basically we're just going to be creating an image. So we're going to be creating this test image and we're going to call it test image when we save it. But what are we actually doing? Well, we're basically going to be from Pillow, we're importing this image class, and then we are creating a test image and we're going to be creating an image from bytes. Now, from bytes is very important. What we're going to be doing here is creating an image using RGB, and then we're going to be creating an image with a height and a width of 2, and then we're going to be passing in a byte array. Now, what a byte array really means is just that this is going to convert whatever is passed to it into bytes. And in this case, it's just an array of a bunch of values here. So let's go ahead and run this. So specifically, if you don't know how RGB works, you can also check this video up here. I have a lot of videos. I'll also leave a link in the description. Basically, this is the red, green, and blue values. 0 in all of these would be black. 255 in all of them would be white. So this will be white. This will be all red, 0, green, all blue, which I believe makes pink. And then white, white, white. So we went ahead and ran this and we can see our beautiful image. So if we zoom in a lot, we can see it is a 4-pixel image where the top right corner is pink. Perfect. Magical, isn't it? So what we're going to do is, because each RGB value is between 0 and 255, we can actually use those to encode characters, because characters are also between 0 and 255. So basically all you need to do is just create a program that can set specific pixels, specifically RGB values of a pixel, to be specific numbers, and then we can convert those back into text. So let's do that. All right, so the first thing we're going to be doing is creating a function that can create ASCII from a string. So I'm going to paste this in here, and basically we're having this secret value called testing. Then we have create ASCII from string, and let's just go ahead and run this and see what it says. So we have, get rid of that, we have TESTING because we're turning this into a list. And then we also are doing this, which is then creating this. So this would correspond with T, ESTING. So you can kind of confirm that because the T's are the same. All right, how are we doing this? Well, how we do this is we're basically creating a map for each value within a string. So we're basically getting this list of testing. And then within this map, we're going to be, basically what map does is it takes one function as a parameter and then whatever you want to map over. So, and basically it's applying some function to each value within the map. So in this case, this lambda function is going to be running on each of these. So on the T, it's going to get that as character, and it's going to get the ord of the character, which, as you can see here, returns the Unicode point for a 1-character string, which is exactly what we want. Awesome. So now we have a way to create ASCII codes from a string. All right, so now we need to actually create an image that's big enough to hold some type of characters. So let's go ahead and paste this in, which is basically going to be creating, we're going to need to import random. which is just a library that allows you to randomly generate numbers. So we're going to be creating an image that's 500 by 500. And the RGB is going to be random integer between 0 and 255, because that's what RGB can be. These are inclusive. And for value within range, basically it's just going to be creating a number here. We don't really need this, but in order to loop over it, we do. And we're going to do image width times image height times 3. And remember, we need times 3 here because we need to not only be, there's 500 by 500 pixels, but each pixel has an R, G, and B value. So we need it to be times 3. So let's go ahead and run this. And there we go. And we can see that we have a 750,000 length array now, or list, with a bunch of numbers in it. All right, so let's create our image. So right here, we have our RGB value, and we're going to create the image from bytes, RGB, image width, height, with the bytes array of the RGB. So we're just going to do this so we can see what the image is going to look like. So we can go ahead and do that, and we can click secret.png. So as you can see, it looks pretty amazing. It's just a bunch of nothing. All right, cool. But we don't actually have anything encoded into this image. So let's do that next. So firstly, we actually need to create a value here. So let's call this ASCII secret. And we're going to actually assign this to our ASCII result here. So we'll run this again. We don't need to run these again because we haven't changed anything there. But now we can see that we have this value. Now, let's go ahead and paste in some code here, where we are basically going to define a range offset, and then for I in range, the length of our ASCII secret, which again is just an array of integers, basically just this here. We are then going to add in the secret and reset whatever the value is. So for RGB I plus some range offset, we're going to be setting the secret. So let's go ahead and call this secret 2, and let's run this. Okay, so here's secret 2. Can you tell a difference between secret 1 and secret 2? Probably not. But secret 2 has a super secret message in it. Testing. But you know what? Let's make our message more fun. Let's call it Jake is cool. All right, but what if we want to decode our message now? Right? We have our secret 2, but let's actually decode it. So let's create a new block, and I'm going to paste in some code here. So we're going to load secret 2, and we're going to load this using image.open. This is going to load the memory. This is going to load the image into memory, and then we're going to create this IM object from doing decode.load. And what that actually does is it loads in basically the whole image into this IM object, which allows you to get values from it. Now, all we're going to do here is basically get all of the values from IM 100, and then we're going to be adding on the I. Actually, let's make this the range offset because we want it to actually be offset at the right time. All right, so we're going to go ahead and create our letters here. And then once we've done this, let's print out our letters. Play that. All right, so we can see that we have all of our values here. Now we want to get the message. So we're going to create this here where we have our letters, and we're going to basically, for each letter, we're going to change it into a character. Again, using map. And let's go ahead and print message. And we can see here, we get a bunch of garbage. I just remembered this actually shouldn't be 300. This should be range offset divided by 3 because, again, this is RGB. So we're going to go ahead and run this. And then we can run this. And we can now see that we have Jake is cool. Pretty cool. Now, what if we want to go a step ahead and actually make this a little bit more difficult for people to decode? So one way we can do that is by adding in a salt. Now, basically what that is it's a way for us to create, to basically change our ASCII values into something that is a little bit different. So we're gonna create a block up here and paste this in here. So we're gonna be creating a salted list from our ASCII secret. And then we're going to use our salted list here and here. Now, what the salted list is basically doing is to salt the value. It's just taking the value and it's adding whatever our salt value is. And then to unsalt it, it's just undoing that. Now, we're just calling this using map again to create our salted list. Now you can make this whatever you want, right? You can add 50, you can take away 50. Whatever you're doing though, make sure that you can do it and then undo it. And also you have to be mindful that if it becomes a negative number, it doesn't work anymore. So if you have it go below 0, maybe wrap it back to 255 or above 255, go back to 0. I'm just going to keep it simple for the sake of this video. All right. So if we run this and then we create our image, there we go. So now we've created our image and there it is again. Looks pretty incredible. Then we can go ahead and see that we have, when we try and decode it, we're going to get all these random numbers. And when we try and get our message, we're going to see it doesn't make any sense. But that's because we now need to unsalt it. So in order to, rather than just getting our letters here, we're then going to add another step. And we're just going to say our unsalted letters are our letters going through unsalted. And we're going to go ahead and add this to here. So now if we go ahead and run this, and then we run this, one thing you might actually need to do though, is that because unsalted letters is going to basically do this, and it might result in something being negative, which you can't do a character value for, is we're gonna actually change this to be a non-zero list. Is we're going to add another thing here to non-zero this. So basically what this is going to do is that it's going to filter out any values that are where x has to be greater than 0. And then we're going to use this here instead. So we're going to run this, and now we can see our message perfect as could be. Now, just as a bonus, what if we want to encode our data in some other type of image? Well, let's go ahead and do that. So we can go ahead and paste this in here, and we're going to basically open up the SAMI image. We're going to get the width and the height of the image. Then we're going to load it just like we did before. Then we're going to, because each value within this is actually a tuple of 3, we're going to create a new list where we're adding each pixel value for the SAMI image, which is this incredible image here. And then we're going to create the new SAMI. Perfect. So all we need to do is just do this and add our salted list to the new SAMI list. Awesome. Now, if we go ahead and run this here, it will take a couple seconds. And if we go and check out secret 3, once this is done, we can see we now have the SAMI list, or the SAMI file. Now, but the real question, is the data still there? So all we need to do to verify that is just open secret 3, and well, let's see what we get. So we open that, we get this, and Jake is cool. Wow, it's crazy. Now, if you look really close, we might be able to see it, but to be honest, it's kind of hard to find. So the data's there, but you just can't see it. So that's it. That's all for this video. I hope you enjoyed. This was kind of a strange thing I did a long time ago to just kind of play around with images, but I think it's pretty cool. So if you like this video, please drop a like down below and please consider subscribing. It really helps out. And until next time, remember, I'm Jake, you're awesome. And this has been Encoding Data into Images. Cheers.